In this video, we will derive the equations of rotational motion. First of all, we will derive the first equation motion, that is omega equals to omega naught plus alpha t. So let's start. First of all, let us consider a rigid body rotating about a fixed axis with angular velocity omega and constant angular acceleration alpha. So by definition of instantaneous angular acceleration, we can write it as alpha equals d omega dt. This is the instantaneous angular acceleration, and this is our change in angular velocity and change in time. In the next step, we can write it as d omega is equals alpha dt. Now let's suppose that at time t equals 0, the initial angular velocity was omega naught, and at time t, the angular velocity was omega. This is our equation 1. Now putting these limits and integrating equation 1, we will get, so this is our omega naught to omega and this is our 0 to t. Now if we take the integration of d omega, it will be omega and limit is omega naught to omega, and alpha will be outside, so it will be t 0 up to t. Now if we put the limits, we will get final minus initial equals alpha t minus 0. So we will get omega equals to omega naught plus alpha t. So this is our first equation of motion. So this is the first equation of motion. Equation of rotational motion actually. Now let's derive the second equation of motion. Now the instantaneous angular velocity can be represented as omega equals d theta by dt. This is the angular displacement and this is the change in time. So in the next step, we can write d theta equals omega dt. Now let's put the expression of omega here. So this is omega naught plus alpha t and dt. So it will be d theta equals omega naught dt plus alpha t dt. Let's name it as equation 3. Now again at time t equals 0, the angular displacement was 0, and at time t equals t, the angular displacement was theta. Now integrating equation 3 within the above limits, so we will get omega naught dt plus alpha t dt. This is 0 to t, 0 to t and 0 to theta. So it will be our theta 0 to theta, and omega naught will be outside, so it will be t 0 to t plus alpha will be outside, so t dt, integration of t dt is t square by 2, that is x to the power n plus 1 by n plus 1, so 0 up to t. Now putting the limits, we will get theta minus 0 omega t minus 0 plus alpha by 2 t square minus 0. So it will lead to theta equals to omega naught t plus half alpha t square. This is our second equation of rotational motion. Second equation of rotational motion. Theta equals omega naught t plus half alpha t square. Now let's derive the third equation of rotational motion. To do that, first of all, again, alpha is equals d omega dt. Now let's break this. So this can be written as d omega d theta times d theta dt. D theta and d theta gets cancelled, so d omega dt. So it can be written as this. Now d theta dt is omega. So it will be our d omega d theta times omega and alpha. Now in the next step, we can write it as omega d omega is equals alpha d theta. Now the limits at time t equals 0, initial displacement, angular displacement was 0 and initial velocity was omega naught, let. And at time t equals t, theta was theta and omega was omega. So putting the limits and integrating that equation, so omega d omega is equals theta alpha d theta. Limits are omega naught to omega and 0 up to theta. Integration omega d omega is omega square by 2. Limits omega naught to omega and alpha will be outside, so integration theta 0 to theta. So this will be half omega square minus omega naught square and alpha theta minus 0. Now if we cross multiply it, so it will be our omega square minus omega 0 square is equals to alpha theta. So omega square equals omega naught square plus 2 alpha theta. This is our third equation of rotational motion. Third equation of rotational motion. So we got our three equations of rotational motion. First one was omega equals omega naught plus alpha t. Second was theta equals omega naught t plus half alpha t square. And third was omega square equals omega naught square plus 2 alpha theta. So these are equations of rotational motion. Thanks for watching.